Hey folks, let's talk a little bit about site suitability analysis. So this week in class, we did have a couple of things that accompanied the lecture. We did have there it is, Desmos activity. So if you haven't done that, click through this and you'll get some general ideas about site suitability and how to choose ways to rank, how to choose criteria and assessing the importance, rank, or influence of those criteria. We also had a site suitability additional lecture that I used. It's Google Slides that you can find on the Canvas pages too. But here we are with our big question, which is the first step in thinking about your site suitability analysis. Is we are looking at San Diego County and where we can site electric vehicle charging stations. And as you go through the Desmos activity, you'll learn that there are some rebates in San Diego County for businesses to site EV charging stations near certain businesses, multifamily housing, and then there's extra money set aside, earmarked for low-income. Let me see what it is. Or misstate it. Is earmarked for sites in disadvantaged and low-income communities and multifamily housing. So our whole example is really based on, for me, identifying those areas. And in class, we worked through different ways to rank those criteria. The other thing we're going to be looking at a lot with this exercise is using Model Builder. So you may have used Model Builder a little bit in the past, but Model Builder is really important for suitability analyses because we can go back and change values a lot easier in a suitability analysis if you have a model than if you have to start from scratch and do it all over again. So we'll be looking at it a lot through these examples. Let's start with our first two values. So in class, we came up with a bunch of different criteria. We could rank suitable locations for electric vehicle charging stations, but we're sticking with 4 for this analysis just to keep it simple. So we looked at location of public electric vehicle charging stations. We looked at major roads, and these two, the other two we looked at were median income and land use. So EV charging stations, major roads, these two fell into a category of criteria that we're looking at a proximity value. So we want to know for charging stations, we want it to be a certain distance from existing charging stations, so we are getting a better spread, a better coverage if they're not right on top of each other. And for roads, it's the opposite. We want it to be closer to the roads, so drivers don't have to get too far off the highway. So when we head over to our Model Builder, oops. This is what I want. There we go. We can see that I pulled in a tool, Euclidean distance, to assess that distance or that proximity. I could use a buffer and then convert it into a raster format, but with Euclidean distance, by putting in our location of our charging station, the output cell size, etc., this will calculate a distance from our location and convert it to a raster at the same time. So it's just one less tool to be aware of, one less tool to worry about. So I did that twice, one for major roads, one for Euclidean distance. So let's go back and look at those results and we can talk about them a little bit. Okay, here is your output. Oops, that's from roads. From electric vehicle charging stations Euclidean distance model. So we can see that we've converted our data into a raster automatically using this tool. We are also seeing that areas that are very dark are closer to electric vehicle charging stations, and as the black moves into gray, you get further and further away. You may also note that I have, in the model, I can just open up one of these tools. In the model, I set a bunch of environments. So, oops, there it is. So mainly that I'm using a mask and a processing extent of the county. So my data sets fill out the entire county. So we can compare and get a full view of the entire county, except for the water area. We can look at the roads results. Let me turn some of this stuff off. Turn our roads on. Same idea, further away in white, closer together, dark. So opposite. The criteria here are opposite. Roads, we want to be closer. EV charging stations, the further away is fine too. So those are our proximity data sets. The next two data sets for our criteria, I'll talk a little bit about how I simplified them and got them into a raster, are our land use categories and median income. Let's start with median income because it's a bit simpler and a bit more straightforward. So let's change the color here before we do that. Okay. For San Diego median income, this is categorical data and it's just a straight polygon to raster conversion. We aren't concerned about distance. We just basically want to turn these polygons into raster grid cells. So we can use that polygon to raster tool and fill in the median income. We can set the cell size. We can set environments, which we did over here, which I'll show you in a second. The other thing I want to note, I did spend some time going through classification techniques, making sure I could pull out the zero values. So later, when we're creating criteria and rankings from them, I could get rid of some of our lower income, some of our water areas or military facilities that don't have income associated with them. But that's another day. So looking on the model, let's head up to our, where is, here it is, median income. So let's zoom in. Median income using our polygon to raster tool and creating that output. Again, setting parameters in, and you can see as I'm hovering over, it's pulling up the parameters, at least with the output cell type, but also setting that mask and extent, processing extent for our data. So this output, once we run that tool, oops, I need to turn this off. This output will look a lot like our vector data because it's just that conversion raster to vector data, but we're still seeing, this isn't broken down into classes, but we are seeing lighter areas, areas in white or light gray have lower income, the darker areas, blacks, dark grays, have the higher income. Pretty straightforward at this point, converting that to raster data, just a one-to-one. The land use data was the last data set and the trickiest to do. If you've ever worked with the land use data set, you know that it is incredibly complicated and detailed. It has, 1,300 classes. If you just dissolve it by the class number, it will get you down to about 104 classes. So the plan was, or I needed to classify it more. I wanted to pull out certain land use categories that were important to the rebates and certain land use categories that I knew would be very low or should completely avoid. So things like water, military, want to avoid those areas. We also have areas that would rate really well, like multifamily residential, parking lots, public services, things like schools, churches, county buildings, libraries, hospitals. Commercial recreation sites like arenas and the bay and beaches and things like that. The other one, there's something else I was going to point out. And then transportation, we're not going to build right on any transportation site, so I wanted to make sure we pulled that off as a no-go zone. So this was, if you go to the model, this is a little bit more complicated. I first had to dissolve the land use categories down to just the basic 1,300 or 1,100 categories, and then go through, let's open this tool up, go through and add, I should open the attribute table, but add in a lot more features that we needed Yeah, let's just open this up. So I have to add in a new field, which we can't see here because it's already the dissolved one. Shoot. Yeah, so this is that 105 that results from dissolving it down. And then I went through, created another category based on different land use types. And then I actually did that twice because I didn't like the output and I was trying to rethink it. So when you're thinking about the criteria, you're going to have to go back a lot and redo and revise. But then once I got down to those 13 or so categories, I was able to go ahead and use that polygon to raster. And that's what you're seeing here, that same data set, just in different colors. That was the first step, was getting criteria a little bit cleaned up and moving it into moving it from Polygon to raster data. So in the next video, I'll take us through how we ranked the data and go from there.